Hello, my name is Mike Tessier, and we're going to cover scanning in this topic. There really are some steps that are involved with scanning, and in this section we will be covering the steps and techniques used to properly map a target network, fingerprint and identify the operating systems of those resources within the network, and then perform system enumeration and analysis on any accessible ports and running services to properly evaluate any potential vulnerabilities associated with those target hosts. There are many tools and techniques that can be utilized to accomplish these tasks. Each tool has its own benefits and limitations. This is important to consider throughout each step of this process. There is no one single tool that can nor should be utilized as the only mechanism in which to achieve the resulted outcome. There should be many tools in your toolkit. It is ultimately up to the target network, its configuration, and those detection mechanisms in place that will guide your operation and help you choose the right tool and technique that will be utilized. So with anything else, there's always a methodology. The first step in that methodology is to truly understand your network. And have you listened to the network itself? I mean, I know that sounds kind of odd, but it really is. Have you listened? Have you started up a listener, such as a TCP dump, and wait, collect traffic, analyze what's actually occurring on the network itself, and start noting those hosts that are up and actively communicating on that network segment. This helps you map out your target network. Secondly, use active scanning to fill in those gaps that you are unable to complete while doing analysis of the PCAP as a result of the collected file via TCP dump. This allows you to limit the amount of scans that you have to run. The more is not the merrier here. The noisier you are on this network, whether coming from the outside and in or even internal scanning, the better, I won't say better, the more likely it is that you will be detected. You should not need to run, and I would not recommend that you run a deep scan to determine which exploit to use. A simple touch tool or identifying the correct protocol or the OS with a proper service pack identification is really all you need to achieve at this point. Just running a deep scan to determine which exploit to use, you're tipping your hand or raising your threat profile, if you will, within that target environment, which is something that we definitely do not want to do. You also want to watch out for uncommon port usage. If you see something that just doesn't look right on the network, a very high ephemeral port that normally isn't bound to anything, typically that means something's up and you want to investigate that. Security products in particular can listen on specific ports which identify themselves as such, and typically it's an uncommon usage of a port assignment. And then finally, the tools that you can utilize to do this. We've already discussed a couple of these. TCP dump in conjunction with Wireshark to be able to perform analysis based on the network traffic that you're actually collecting. Remember, it's always listen first before you jump off into the deep end. And then Nmap. Nmap is a very good scanning utility. It's been around for quite a while. And we will cover that a little more in depth in the following slides and with some laboratory exercises later in the topic. So, stealthy scanning, and really it starts with host discovery. In this section, we'll cover just that, host discovery. And what is host discovery? Well, it's the information gathering on potential resources within that target network itself. The goal here is to limit the connection-oriented traffic, and we'll get into that a little more later on, but you need to remember we're only gathering information at this point, information that will be used at a later time during the operation for more intrusive scans and techniques. At this point, it's best just to use common ports and protocols that blend in as much as possible among legitimate traffic that's not outside the baseline traffic for that target network. So really, finding targets or target discovery can be achieved in several ways utilizing several different tools and protocols. We'll begin with ARP. Command line syntax to send out an ARP scan within Nmap is the command Nmap with a dash lowercase s lowercase n option with an IP address or a subnet that you would like to scan. Ping is another utility that can be utilized. It's a system administration tool. It's been around since the early days of computing, all the way back to 1970 with Unix. The command is very simple: ping with an IP address. Nmap will do the ICMP echo request prior to scanning a target for ports to determine whether or not that target is actually up or alive. So just by running the Nmap scan, it is running that target discovery utilizing an ICMP scan up front to determine what targets within that network segment are actually alive. NetBIOS on the Windows side, command line syntax is very easy: MBT-STAT or MBT-STAT with a dash A with a host name if you know it, or the dash capital A with the IP address if you do not know that host name. We'll get into a little more of what each one of these can do in subsequent slides. This is really just a good intro to what we'll be discussing. Passive collection, broadcast protocols, but again, this is utilizing TCP dump to create those PCAPs that you can then do analysis on within Wireshark. I cannot stress to you enough, everything that you can collect over passive collection is just one less thing that could potentially tip your target off when it comes to scanning, enumeration, or exploitation. As much information as you can collect passively, the better off you will be when we get into more of the intrusive techniques later on. So how do we find targets? Again, ARP, it's very simple, utilizing Nmap with a dash SN switch and an IP address. This actually sends out a ARP request on the local subnet. It works very well, and the great thing about this is that it's low level. It blends in with other legitimate ARP traffic that's already resident on the network. It blends in very well with a baseline. If someone's already baselined their network traffic, this is something that should not be flagged on an IDS or an IPS. And it's never, ever blocked by the target. They will never block ARP traffic internally on a network. If they do, I would hate to have to work on that network. The shortcomings is that you cannot route this outside to another subnet. So you're really locked down into that network that you're currently investigating or on. ICMP, again, it's an administrative tool. It's been around for quite a while. It's a ping. Ping with an IP address, and again, Nmap will do the same thing prior to launching any active, and I use that term active in quotes. I know you can't see that, but before it will actually go ahead and start looking at the ports and protocols, with a port scan, it will do that ICMP request to that target to determine whether or not it's alive. Advantages can be used on a local or outside of the local network that you're on. It's layer 3, so you're going to receive that time to live, and we're going to talk about that a little more here in a bit. But the time to live value will help you in the preliminary stages of identifying the target OS. Shortcomings of it, however, is that typically it is blocked by a firewall. Not necessarily going from inside out, but definitely from outside in, and not necessarily within the internal network itself, though if they are running some kind of internal IDS or even firewalls to keep certain segments of the network segregated from other sections or segments of the network, it could be blocked there as well. Some network IDSs or intrusion defense systems create logs if it sees ICMP traffic traversing the wire. Typically, it's used by sysadmins and hackers, so it's a good tool to have running on your network. Just be careful and understand that by not monitoring who is utilizing ping or ICMP on your network could be a problem. Continuing on with finding targets, we'll talk about an ICMP traceroute. The Windows command line syntax for this is traceRT with an IP address. On the Unix side, it is traceroute with the IP address. Within Nmap, you can run a traceroute as well. The syntax, as you see right there, is very easy. Again, with the -SN switch with a capital P, lowercase n, with a dash dash, trace route with an IP address. The advantages of this, it resolves IPs to router names, which is pretty handy if you've ever taken a look at a TCP dump PCAP. Being able to determine where those devices are, and when you're building out your target map of the network itself, comes in very useful in later scanning and enumeration operations. The shortcomings of this, however, is that it can and usually is blocked by a firewall. So if you're going to be going out from the inside out or from the outside in, typically an ICMP traceroute is going to be blocked by a good system administrator. And really, I'm going to be honest with you, internally, unless you're dealing with some very, very heavily segmented networks, you're typically not going to need to run it on the inside. So just be cognizant of that. It is very good to understand how this process works and what it can be useful for, but your mileage may vary. NetBIOS, we talked about this earlier. Typically, you're talking about Windows networks, MBT stat with a dash capital A, again with the IP address if you don't know the host name, lowercase or a dash lowercase a with a host name if you do know it. This blends in very well and is consistent with Windows communications internally on a network, and it will not stand out from a baseline that has been conducted of the network traffic. It provides you a lot of really, really good information about the host in the lines of, does it belong to a workgroup or is it part of a domain, and what is the name of that workgroup or domain? The host name of the target itself, that target's MAC address associated with that network interface card. It also helps you identify networking and print sharing that may be out associated with that target as well. It looks odd, however, if this is sent to a Unix-based OS, and don't laugh, I have actually seen this happen where someone is actually running NetBIOS commands against a Nix box or target, and trust me, it definitely sticks out. So again, be careful and cognizant of what you're doing. Always maintain good situational awareness of the targets that you're going after and that target host specifically, and don't do something that shouldn't be happening. So to wrap this quick module up, as with anything else, there's a methodology that's being utilized, for host discovery. And we talked about that briefly, but you have to understand your network, and it starts with listening. Have you listened on the network and ran TCP dump and done some analysis of those PCAP files utilizing Wireshark? Use active scanning only to fill in the gaps that you cannot pick out from passive scanning or passive identification of what's happening on the network. That really is going to help you be a better operator. We talked about the different target discovery mechanisms that are out there utilizing ARP, ping, NetBIOS, and again that passive collection. We talked about some of the advantages and shortcomings of each one of those protocols, if you will, and where they should be used and how they can be used effectively. In the next module, we'll be talking about stealthy scanning and get a little more in depth with the OS fingerprinting process, and that topic will follow right after this. Thank you.